everybody. Keith over here.
On display at Sacred Heart Diabetes Treatment Center.
Yeah, you think good work. A lot of good work.
Thank you, Keith.
And
I'm
he's
tired.
getting tired. I was going to say he's getting tired. So, okay, so for those that don't know who JABIL is and really what they all do, you do know them, you just don't know that you know them because it's, what was it, the top 150 devices that we use has some form of their technology in it?
Yeah, about the top 150 products that or brands we use every day is associated with JABIL manufacturing in some way or form. You know, yes. And they have the NIPRO division, which is also their health and medical division, which Girish is going to be talking about today. And a lot of neat things coming out of that. Matter of fact, JABIL just partnered with Johnson & Johnson to take over 14 of their manufacturing facilities, which is
pretty impressive.
Pretty impressive. JABIL is doing a lot of good things in technology.
Thank you, guys. So as I would like to put it, JABIL manufactures everything from cream cheese tubs to aircraft parts.
That works, huh? That's the truth too, isn't it?
Yeah, that's true. Yeah.
So, okay, so what do you do within JABIL? I see strategy or strategic capabilities in your title, so think about it.
So as I said, JABIL manufactures everything from cream cheese tubs to aircraft part, medical devices, consumer devices, everything in between, right? So these different products are manufactured in vertical divisions that service specific customers and specific brands. Whereas we in the strategic capabilities group work across all these divisions and try to bring in new manufacturing technology that JABIL customers can use in order to manufacture the products. Specifically, I'm kind of focused on integrating electronics into non-traditional surfaces such as plastics and plastic sheets and so on and so forth.
Very cool. Okay, so what do we need electronics in plastic for?
So we need electronics in plastic in order to really realize this dream of a connected ecosystem.
Yeah.
So if you use a product and if that product can sense, can communicate, that product can allow you to collect data, and if it allows you to collect actions that are good for your well-being, good for your business, and good for society.
Yeah, very cool. So I know today we're going to talk specifically about this diagnostic catheter, right? Because it can go inside the heart.
Technology that is used in this diagnostic catheter is what JABIL is working on, and the application can be both invasive and non-invasive, but it's all about connecting extremely small sensors to extremely miniature wires so that you can add and integrate sensors into devices such as catheters.
I heard you were the man to connect those actually. Physically, you got in there and soldered them, right?
Well, not really, but I'll take some. Yeah, so it's devices like these that can, or the technologies like these that can also improve devices like continuous glucose monitors and so on and so forth. Yeah. So you can collect basically a lot of data such as pressure or temperature and so on. So
So how did this come about?
That the industry and the brands are driving towards adding electronics to products. So we take a look at a wide variety of different products and identify use cases where integrating electronics and integrating sensors would be challenging. Then we go back and look into our toolkit and figure out what are the different ways that we can use our toolkit in order to add these sensors. For example, a few years back, we added a simple camera from your smartphone to a feeding tube. So now a feeding tube that traditionally the physician wouldn't see where the feeding tube was going. Now as the feeding tube is being inserted, the physician can see.
So you can drive, right?
Yeah.
Not end up making
essentially.
mistakes. So this is what I picture. I picture you guys are all sitting.
On the core technology that enables that, the next generation solder or a process that allows you to print inks and so on and so forth. So although as a system level you see this functionally fully integrated product, at the heart of it are different types of processes, and folks like me work on these different types of processes that enable the manufacture.
Your office is one big whiteboard, isn't it?
It's one big one.
Yeah, very cool, very cool. So, okay, so this becomes a really a revolutionary thing within the healthcare industry, I think. But how long before this is actually in market or in hospitals or being used?
So I think the time it takes to get to use depends on many different things. So we create this toolkit for manufacturing, but then we have to identify how reliable it is. If it goes into a particular product, what are its approval steps and regulation steps? Is it a clinical device or is it a consumer device?
Yeah.
Which customer is at a cycle where they want to come up with a product that makes use of production,
sure.
And sometimes it goes into production within 6 months.
Yeah, especially I would think with being inside the human body, they really want to make sure they don't mess up, right?
Yeah.
So, I think one of the things that Steen has explained to me, which I just thought was very neat, is and you guys work with a lot of people.
Yeah, so we are around 200,000 people strong all over the world.
Wow.
Yeah, and we have about 26 facilities here in the US as well.
Wow, that's crazy.
Yeah.
And how many do you get to hang out in? Just one?
Usually just one, but I do get to travel quite a bit.
Yeah, you can bounce around to the other ones. Yeah. So, and they're all over the place.
They're all over the world.
In the US, and then
just it's
Antarctica,
not in Antarctica, but
yeah.
Pretty much every continent.
So, what do you think is your next project after this thing?
We are continuing to work on evolving the printed electronics technology. So we are kind of looking at different material sets such as inks that can replace traditional electronics like copper and silicon. And we are looking how to combine the processing power you get with silicon and the flexibility and the conformity you get with these printed inks, so that you can make such conformal, flexible devices that people can wear. So commercializing this is kind of what we are working on.
Yeah, that's the next step. So what was that you just said you
So this essentially is a flexible hybrid device where you're able to print circuit traces and then attach standard electronic components to it. So if the traditional printed circuit boards are rigid, whereas these structures are flexible and conformal so that they can wrap around your
So now you're into the world of 3D printing, or you're printing circuitry on 3D objects.
Yeah, we could. Yeah, so you could potentially create electronics on 3D objects.
Yeah. So the last place I was in was an accelerator part of the state's entrepreneur ecosystem, and the lady in the office next to me, that's what they were working on. They were doing 3D printing on. They were doing printing onto like ball bearings and things like that, so you could get data back from it. So, which just blew my mind. So I told her, one of y'all is going to be. You're going to be the person. It's coming, right?
It's coming.
It's coming. See, Gary Vee was right. 20 years. It won't even take 20 years. It's going to be like 5 or 10, man. That's going to be awesome.
How it applies to, say, a device that helps a diabetes patient or a device that helps a sick patient.
Levels doing, and this wearable, I think too that a couple years ago I saw where JABIL had come out with, and we have a children's hospital here locally. This started to be interesting, but babies, they're small, preemies and all. It's hard to put in use invasive devices.
Sure.
They were able to come up with a baby blanket, actually monitor all the vital signs.
Yeah, so you didn't
what
have
you're
to,
using.
you didn't have to.
So those are some.
That's cool.
A lot of data.
Yeah. So, like, what So what data does this object get specifically?
So this particular one is a patch. This is an ECG patch. Okay. So if you think of the current way ECGs are done, you have these buttons. These buttons get hooked to a wire. The wire gets into a box, right?
And you get a beep, beep,
yeah. So you basically have a patient that's kind of tethered. So the new wave is to kind of untether the patient. So you connect them wirelessly.
So I got Wi-Fi. That's awesome.
So what this device does is it replaces that button with a printed ink.
Okay.
And then all the electronics is in a flexible substrates on top. And then there is a flexible battery here. And then a person can wear this and use it as a consumer monitoring device for ECG.
Now, how do I make sure that Stan doesn't go monitoring my Wi-Fi EKG?
And that's something that the folks that design the communication protocols have to embed, have to follow certain standards, have to install certain security features, and so on and so on.
Yeah.
Right.
Very cool.
So from a manufacturing perspective, our job is to make sure to add electronics is as small as place as possible, as well as add electronics to different types of structures and substrates. And then there are our counterparts that work in the communications, in the electronics, in the algorithms, and so on and so forth, that take care of the other features.
What do you think this opens the door for other technology coming behind it? What do you think this is the start of?
So essentially, the integration of sensors allows you to really realize this connected ecosystem. And then really, if you can imagine a way to monitor a particular vital, and that vital can be of the human body, the vital can be of a vehicle, that vital can be of a bridge. So if you can figure out a signal that allows you to calculate what that particular being is going through, and then you can use that signal in order to help solve a problem.
Yeah.
Then I think the applications are limitless for such technology.
Do you think this kind of stuff will become
because
it's Wi-Fi, right?
Yeah, for example, in this case, the patch connects to your phone via Bluetooth, and then the phone obviously communicates to the cloud.
Yeah.
So actually, one of the ideas behind the connected ecosystem is if say a diabetic patient is having a sugar episode, right? Then that information is already relayed to the caregiver before the caregiver actually arrives to apply therapy.
They have to be in the same place, right? Yeah.
So it's kind of untethering the system.
Yeah. So we would have a head start on epidemics like flus or any kind of disease that would jump. We would just really be able to regulate things happening, right?
That's actually an interesting point, because one of the applications of this technology is to be able to create lab-on-chip devices, so that you can now have distributed monitoring. So you have these lab-on-chip devices at different places. So instead of taking a sample from a location and going to a laboratory to have an analysis made, you can make the analysis at the spot where that contaminant is.
Live, right? Yeah, and you may not even have to be there physically.
Yeah.
Right? So do you think that scares people?
I think if you can use the technology well and control it, I think there's a lot of good that can come.
I would agree. So when we leave here today, you're going to speak at UWF for the Center for Entrepreneurship, correct?
Well, yeah, they're sponsoring it. It'll be at the College of Health. That'll be this afternoon at 4:30. It is open to the public, and any of our medical facilities, professionals in the community are welcome to attend too. This will be good information for them about our medical technology of the future coming about.
Yeah. So do you find doctors getting excited when you show them this stuff?
I think
they're like,
I think a there is a mixed bag, but I think a lot of doctors want to use technology, but they want to also make sure, because their primary goal is to make sure the patients are treated well. So they want to make sure that the technology is robust, the technology is well proven, and once that's done, starts getting it up.
Yeah. Do you find is the stuff that you
sugar gets low.
It's just going to
they just send a drone out. Robot comes out, ejects me with glucose,
your orange juice, your glucose,
flies up there, and it just bills my credit card directly.
They're not far away from that.
No, they're not.
I think there's just some regulatory things that they are working with. But what else about diabetes, Mike? You've been very busy so far. So
it's growing. We just found out in March while I was in DC that diabetes now has become the #1 condition, costliest condition in the country, at $327 billion a year. That is staggering.
And a lot of it very treatable.
Top 2 is, because as we found out last year on your show as well, top 2 is preventable in a lot of cases because it's through our environment, our lifestyles. So, but type 1, you're insulin dependent, no, that is through pancreas problems and not being able to produce the hormone insulin to control the body when it has food intake and all that. So yes, there's a lot going on, and research is very important. A lot of the universities that rely on research money, that's one reason that I go to DC every year, to lobby Congress for NIH and CDC funding, because a lot of this goes to people like Dr. Girish and also Dr. Gu to develop these products, and then they go to people like JABIL. Can you help us make this, get this on the market? Which is always needed. It takes money to bring this new technology to the out to the public. And also brings me to another one that Dr. Girish may want to talk to us about. One of the things we hear about is, why does it take so long for technology to come about? We know that there's FDA rules, but there's also been talk we need to revolutionize the pharmaceutical and medical industries. Do you want to give any insight on that?
So I think from a manufacturing perspective, again, I'll go back to kind of my drumbeat, right? Is about adding sensors. So one of the examples of adding sensors is to an inhaler. So we have an inhaler that has a whole bunch of sensors, and when the pressure, it measures the temperature, it measures what time they took the dose, it measures at what angle they took the dose. So as you can see, now if the companies can harness that data and make good insights out of that, that can change the way medicine is taken, right? So earlier you just take the medicine whenever there is a 50% chance that you may not take medicine because of there is an adherence issue. So by adding these sensors to these devices, you can change the way medicine is delivered and taken by patient, by making them more aware of the information that is necessary to make that decision.
And you would know of any of the good or bad effects immediately, right? Yeah. So how long before one of those EKG patches is an insulin distributor already? And you just go, and if it picks up, and if your insulin's dropping, it just goes ahead and sucks through your skin. That's the next idea. I just gave it to you, didn't I?
I mean, it's one of the ideas, right? But again, it really depends on how the product companies want to organize the delivery of the next generation of the device, right? Our job in the ecosystem is to enable that from a manufacturing perspective, right? So I think time scales are really dependent on how the ecosystem around us is changing to make this.
Do you find people being very accepting of the change coming, or is this sort of?
So from a consumer lifestyle perspective, we notice that wearables are exploding, that continue to grow. How the patients or the consumers make use of that data, I can tell.
Yeah.
But I think there is an increasing number of people that are using wearables in helping.
Devices that Girish was just talking about with us. Phones are now with our cameras that he was mentioning that they develop and all this is changing our lifestyle for the future. So really, a lot of our medical is changing.
In a tube, it's going to scan us and fix everything, isn't it?
Yep.
It'd be cool, wouldn't it? It'd be cool. Or what's the movie? Tron, where he just changes the code, puts it back in. That's it.
Yep.
So very cool. Well, is there anything else that we need to cover that I might have missed, or?
No, I think the biggest thing is we welcome everybody to come out from anywhere in the community this afternoon at 4:30 to the UWF College of Health building at 4:30.
And
join us.
Do the students get to do a little meet and greet too, right?
They're going to do that at 3:30 in the same building.
That's cool. It's very neat of you to do that. I think.
No, it's important for us to also work with the future stakeholders, both as employees as well as consumers, in order to foster it. So I guess it's part of our job.
Very neat. So I want to thank you for joining us today. I really appreciate it. I could sit here and pick your brain for hours, but I know you've got places to go.